Old McKelly had a farm, E-I-E-I-O, and on his farm he had a robot tractor, a flower picker, and, oh, looks like we're taking on a new member of the team. If I'm honest, I'm as comfortable on a real farm as a cow would be in a data farm. But I'm here to see a world first. As farming gets more automated, it might not come as a surprise to know that many modern tractors will drive autonomously in a straight line. Nearly all of them, though, need a human operator to turn the corners and generally be the brains of the operation. What's interesting is that in this one field in Shropshire, in the heart of England, every single stage of the farming cycle, from preparing the soil to harvesting the crops, is automated. Welcome to the hands-free hectare. The researchers at Harper Adams University, along with agricultural engineers, have already completed a whole year of sowing, growing and harvesting spring barley, all using autonomous machinery and without a single human touching the crops. And how have you made them autonomous? It looks like you've had a go yourself.
So everything we've used is off the shelf, you could buy yourself, and it revolves around the open source autopilot from a drone. And then we've had to adapt our tractors' manual controls with motors and actuators.
And we'll come back to the hands-free hectare in a few minutes.
These machines have an advantage for farmers because you don't need as many people operating or supervising them. And of course, farming automation is happening across the board. Last week we saw a pepper picking robot in Australia. And as Brexit threatens to cut down the number of people available to work on the land, this could become increasingly important. Jen Koopstake has been to the Netherlands to see some more developments in automated picking.
Selective harvesting of delicate crops like strawberries, mushrooms and flowers is physical and repetitive work. The crops are easily damaged, resulting in financial losses for farmers. Traditionally, these industries have attracted migrant workers, but with standards of living rising across the globe, the work is not as attractive as it once was, leading some farmers to consider how robots could fill in the gaps.
Many countries around the world are facing a labour shortage for harvesting crops, including here in the Netherlands, which has the world's second largest value of agricultural exports. It's the world's largest exporter of cut flowers. But are robots really ready to pick up the slack from human workers?
At Wageningen University, researchers certainly think so, and are working on all kinds of problems in the fruit and vegetable supply chain, from testing firmness of fruit to manual handling. Firmness is usually tested by hand, by physically cutting the fruit and sticking a probe in it. It's a labor-intensive process, and the fruit is left damaged and can't be sold. Researchers think robots will provide a more accurate and hygienic solution that doesn't damage the fruit.
It's a funny robot, right?
So what's it doing?
It's a prototype for fruit inspection.
How does it do that?
With near-infrared spectroscopy.
Oh, wow.
Yeah.
So he's happy with that apple?
Yeah, he is happy with the apple. Yeah, you can look how happy he is.
Yeah. Do you think he's going to go for a pear next?
We don't know. He decides.
He decides.
It's an autonomous robot.
Oh.
Yeah. So yeah.
A key breakthrough will be getting these machines to work faster than humans and in a commercial setting. Robots are already at work in the greenhouses here at Florensis. And these machines can autonomously plant 2,400 to 2,600 cuttings an hour, compared to a human working at a still impressive 1,400 an hour. It recognizes the top and bottom of the cutting and even shakes the conveyor belt to free them if the camera can't get a good look. The only jobs left for the workers here are scattering the cuttings on the machine and quality control of the finished product.
So before, how many human workers would be on this line?
Yeah, on a line like this, with this capacity, about 10 to 12 people needs to be sticking manually. Yeah.
10 to 12, and now you have how many?
2. Yeah.
Okay.
Fewer people does not mean less work can be done.
At the end of the game, you can work 24 hours of the day. You can save, let's say, up 60% of your labor cost. There are many aspects which is going to help the total process. I believe and I'm convinced that this is just a start, and absolutely this will replace the human being.
Bringing autonomous picking robots beyond prototypes to actually working in the field has been an immense challenge. But Dutch company Cerescon is ready to sell its white asparagus harvesting robots. It has sold one to a farmer in France and are building more in its headquarters near Eindhoven. White asparagus are more expensive than the green variety. It grows under the ground. To stay white, they need to be picked before seeing any sunlight.
We actually inject an electrical signal into the ground, and we have these sensors which dig through the soil, and when they approach the asparagus, they actually pick up the signal, and the closer you get to the asparagus, the stronger the signal gets, and when it's above a certain threshold, we know, oh, now we're very close, so we immediately pull back this sensor, and then we know where it is. The asparagus is actually conducting electrically the signal because there's a lot of water in there. So basically the difference between water content of the asparagus and the sand, that makes the difference how we detect the asparagus.
Cerescon says the 3-row version of the machine can replace up to 70 manual hand workers. Is this machine more efficient than a human?
Oh yes, yes, enormous, much more. And also you have better quality asparagus because we detect them subsurface, they do not become violet and they don't flower. And we have less subsurface damage. With the current way of manual harvesting, they lose 30% of the crops with subsurface damage. And with our machine, we think we bring it back to 10 or 15%.
We're seeing the race to develop these robots for market accelerating around the world. This is the Agribot. It's being trialled in Driscoll's berry fields in California. Here in the UK, farmers are experimenting with the technology too. There are fears about the availability of migrant workers post-Brexit.
I understand how an indigenous population in a country like Britain may be reluctant to have a career in hand-picking strawberries, and so it tends to be done by migrant labour. There are access issues with that with Brexit and the like. We're keen to maintain, as a farming industry, good access to that labour pool at the moment, but we can see that in 5, 10, 15 years' time, we may have technology whereby this work can be done by robots.
A lot of work is being done to try and solve the labour crisis in selective harvesting with robots. Perhaps one day farms will look more like car plant assembly lines, and humans picking fruits, vegetables and flowers will become a distant memory.
That was Jen in the Netherlands. Back at the hands-free Hectare in Shropshire, this little autonomous tractor is making its way across the field. This is footage from a proof-of-concept project in automated, sustainable farming, which means looking after the environment at the same time as growing enough food to meet the demands of a population that could reach nearly 10 billion people by the year 2050. But why have they chosen to use smaller tractors instead of the giant modern ones which can cover much larger areas?
So with all the benefits of those big tractors, there's also the problems. And one main problem is the weight of the tractors, and that weight is doing lots of damage to the soil. And that is essentially the squishing and the removing of structure from a soil, which makes it very hard for plants to grow. So we see the solution as the one guy who's driving the big tractor then becomes like a swarm or a fleet manager of these smaller autonomous machines.
Back in the field, I joined Kit Franklin in a cold, cramped control hut.
So what are we looking at here?
Okay, so this is the telemetry coming back from the tractor, so you can see the position of the tractor, where it's got to, and then you can see it meeting the waypoints, turning.
As well as not compacting the soil, there is another advantage to using smaller vehicles. Small sprayers allow for precision farming. Now that means being able to deliver the right fertilisers and pesticides only to the plants that need it.
When you blanket spray, a lot of spray isn't hitting target, it's hitting soil and then just going into the environment. So with a smaller robotic system, we aim to be much more precise and put targeted input. So if we only target the plant itself, we can drop that chemical use by 80% upwards, depending on whose papers you read.
But how do you know which crops need special attention?
Part of the deal with precision farming is knowing exactly what parts of your field need what kind of treatment. Now that's usually done by eye. You would come and look at the crops and the state of the soil. You might even dig up a few samples and from that work out what you need to spray where. Well, here, even that part is automated.
Drones fly autonomously between waypoints, capturing pictures of the field with specially adapted cameras.
So we're looking at multispectral images, so looking at near-infrared type parts of the spectrum.
Under infrared, plants give away a lot.
So we can look at disease stress or nutrient stress and things like that.
And Kit says that even though you'd need a fleet of smaller tractors to do the work of one big tractor, each would cost just a fraction of the price of the big beast.
Our machine that we're using in this field, I could sell you with some profit for £40,000. So you could have multiple of my robot tractors, my autonomous tractors, for the price of your one very large tractor that you currently might be buying.
I feel like I'm in some kind of car sales showroom at the moment. I'm starting to be convinced. Yeah, I'll have 5, please. Yeah.
Yeah.